Hi, my name is Joe Frankham. I'm a professor of computer science at Utah Tech University. Today I'd like to talk to you about a topic known as Docker and containers. One important part of application development is deciding how your application will be hosted. In the early days of computing, a common method for deploying an application involved utilizing a server, either on premises or in a data center. This method has some distinct advantages and disadvantages. Some advantages are that you have complete control over your hardware. Your application doesn't have to share hardware resources with other competing applications. This method will also have some disadvantages. Scaling the application would be very challenging, since you would have to purchase new hardware, deploy the application on it, and put a load balancer in front of it. Also, if your application doesn't make full use of the hardware resources, those resources would be unused, which would be wasteful. The next iteration of application hosting involved the use of virtual machines. Virtual machines make better use of the underlying hardware, allowing multiple virtual machines of potentially different operating systems to share the hardware. This makes for more efficient utilization of hardware resources. Your applications can be segmented from other applications running on the hardware. Scaling becomes an easier problem to solve than a physical server because you need only deploy or remove a virtual machine as needed. One disadvantage is that you still have to manage these virtual machines and make sure that virtual machines are configured exactly as a developer expects. There could be difficulty in managing the development environment, a developer's laptop, and making sure that the production environment, a virtual machine, are exactly the same. Virtual machines can also have a large footprint. The current iteration of application hosting involves the use of containers. This is the topic that we will focus on today. Containers contain everything that is needed to run an application, including source code, libraries, and any other packages. When using this method, we no longer need to rely on what is installed on the host, since everything is bundled within this container. This will help alleviate the common response from the developer that it worked on my machine. Containers also result in a much smaller footprint than virtual machines. Some of the other advantages of containers are flexibility. Even the most complex applications can be containerized. Lightweight. Containers leverage and share the host kernel. They make more efficient use of hardware compared to the VM. They're interchangeable. You can deploy updates and upgrades on the fly. Portable. You can build locally, deploy to the cloud, and run anywhere. Scalable. You can increase and automatically distribute container replicas. The most popular container solution on the market is known as Docker. This solution is comprised of three components: the client, the host, and the registry. Certain commands are run on the client. These commands will cause an action to be executed on the Docker host. The Docker host runs a Docker process and will also store a copy of images that are used. The host will also take care of container management, giving resources to the container, terminating the container, and other things. The registry is used to maintain Docker images. A container is a runtime instance of an image. Whereas an image is immutable or unchangeable, a container can be changed. A container will always run the same regardless of where it is running or what it is running on. A container also runs isolated from your operating system. As containers have a smaller footprint than a virtual machine, you can run them at a much higher density on your hardware. Containers can be turned off and on much quicker than a traditional server or a virtual machine. scaling can be much quicker than utilizing a virtual machine. The creation of an image is done by using a Docker file. A Docker file contains many instructions within it, such as what the base image is that this template should be based on, environment variables that should be set, files that should be copied into the image, commands that should be run when building the image, commands that should be executed when the container actually launches, and several other components are in this Docker file. After you have built your image, you can then take that image and share it with the world or your development team by pushing it to Docker Hub. Others can then in turn build images based on yours by creating their own Docker file with the correct specifications. DevOps teams could configure their tools to pull from your image from Docker Hub as well. Thank you for listening to my presentation today about Docker. I've really enjoyed being here and meeting with you. If you would like to have some more in-depth information about how to run and manage Docker containers, take a look at my tutorial. Thank you.